Hello. Thank you for joining our on-demand webinar today, sponsored by Juniper Networks. Today we'll focus on technology transformation with the focus on leveraging SDN and NFV to empower change. This is part of Juniper's Transformation Management, an NFV webinar series focused on topics around NFV. We already have available online at our NFV pages solutions that matter with SDN, and also business transformation guide to stay differentiated. Those are available online. Today our focus will be leveraging SDN to empower your technology transformation with a deeper look around how the NFV technology and how use cases can really transform yourselves. Further out, we will also have the organization of the future, as well as how to measure the business impacts of virtualization. So I invite you to come back and view those webinars when they're available. This is Wayne Chung, Director of Product Marketing at Juniper Networks, and I will be your host today for this webinar. We also have Scott Sneddon, Senior Solutions Architect. He is our subject matter expert on the technology and how transformative it is. I also have Jitendra Lalula from Professional Services to share his experiences from the industry and customers on how this technology is so transformative. Today's webinar will really hone in on the NFV and SDN technologies, really with a specific theme on how transformational it is. What attributes make it so transformative? What is it that the customers are expecting out of this technology? And ultimately, what is the outcome achieved by leveraging this technology? To really understand the transformative aspects of NFV, we need to first understand the market conditions that's driving these changes. Three pillars of this: the service evolution, the enterprise requirements, and the consumer expectations. Service evolution, let's take a look at that. We all know and have seen over the past few years, application and services are shifting more and more to the cloud. We will only continue to see the acceleration of this movement. Combine that with software innovations, being able to optimize and deliver and operationalize this through automated techniques to further adapt and meet customer requirements, and the ability to adjust and adapt to the on-demand scale, whether that is to scale down or scale out a particular service, or dynamically scale up a particular service at a moment's notice. Emergence of telco cloud, IoT, and 5G are only some of the trends that are really driving these type of innovations. And you combine that with ever-evolving security threats, needing to be very dynamic in nature to be able to address these sophisticated attacks in real-time manners. So this really all bundles around automation being a key principle to the service evolution. Next, let's take a look at the enterprise. Enterprise requirements are getting more and more complicated with the mix of private cloud, public cloud, hybrid clouds. So these are changing use case conditions around it, how you factor into economics, as well as regulatory implications to these type of models. You combine that with the pay-as-you-grow. IT organizations within enterprises only want to consume what they will eat, and therefore the ability to have agile service creation and delivery is key to this pay-as-you-grow model. Combine that also with the policy-driven security programs that we are seeing now for control and assurance. These are really dynamically changing. New and more current policies are needing to be updated regularly. So to be able to facilitate that end-to-end in your network is going to be key. And lastly, around the self-care portal, they want that rapid service delivery, meaning they have an idea, there is a request upon a new service that's required by a department. They want those capabilities delivered in a self-care portal manner, so they can configure it, they can monitor the fulfillment against it, and they can also see really the usage base of it through reporting capabilities. Then you bundle that with the blend of what we're seeing around consumer expectations really bleeding into the enterprise requirements, that of customization, unified user experience across all their devices, meaning all locations, branches, home, workers, and that immediate on-demand service delivery model. So these are the trends that we're seeing that are driving these expectations across the NFV architecture today. So in our webinar series, to really capture the essence of where these changes are being applied to the nature of the service provider business so that they can continue to sustain their long-term competitive advantages in the marketplace, this webinar series has really broken down business transformation, technology transformation, and organizational transformation. Now, in our previous webinar, we covered business transformation that talked about rapid service creation and business models that will drive successful outcomes. I invite you again to take a look at that webinar. This particular webinar will do a deep dive into the technology transformation layers, that of looking at your existing assets of your network, very physical in nature, maybe existing OSS, BSS systems, and then blending that with a virtual infrastructure. What does that mean in terms of combining those two capabilities and continuing to innovate to solve customer challenges? And then leveraging tools such as automation, flexible scaling techniques, and adaptive security models. These all blend into key decisions around the technology and architectures that will drive that success. And in our next webinar, we'll cover off organizational transformation, the culture, the processes, the skill sets really required in order to take full advantages of the NFV capabilities and applying that architecturally across your network. And so with that, we're going to hand this over to Scott Sneeden, our subject matter expert, and he'll walk us through Juniper's NFV reference architecture.
Thanks, Wayne. Pleasure to be here. So Juniper's been involved in this evolution around telecommunications and the venture towards software and NFV for quite some time now. And we're going to talk to you a little bit about the solutions that we have in place and what we've got for the market today. In 2012, a group of representatives from many of the world's communication service providers got together and wrote a white paper. This white paper proposed the idea of using cloud technologies and software to enable telecom transformation and network transformation. An outcome of that white paper, it was presented around at quite a few conferences and things, but the outcome of that white paper was that the European Telecommunications Standards Institute, or ETSI, put together a working group, an industry specification group, to start developing standards around NFV. Over the last few years, we've gone through several iterations, and there's been a lot of development and conversation around these standards. And what we've come up with is the ETSI NFV architecture, which is a standard reference architecture for how an NFV environment might look. There are several components to this reference architecture, and there are quite a few specification documents out there that you can read that go into the details about these different components. But starting at the bottom left, we have a definition for a standard NFV infrastructure. And this is the physical layer where network equipment connects servers together. Servers run a virtualization layer or a cloud layer to support the running of virtual network functions on top of that cloud layer. So the idea here is that we're doing things in software or in virtual machines or containers or that kind of technology that we would traditionally do on network hardware. So the NFVI is the infrastructure to support those workloads. And then moving up from there, we would have virtual network functions, or VNFs. These are the actual virtual machines or applications that would support, let's say, an EPC application or a firewall or something like that. But that function is an application running on top of a virtual machine, probably Linux-based, running on top of that NFV infrastructure. And then over on the right, there is a set of definitions around NFV management and orchestration. It's often called MANO, or the MANO layer. And within that, we would have virtualized infrastructure manager, or the management layer to manage the cloud itself. We would have VNF managers, which are potentially just traditional network management platforms, or these could be purpose-built applications that are managing those virtual network functions themselves. And then on top of that, we would have an NFV orchestrator, because the whole promise of this NFV model is that I can seamlessly orchestrate end-to-end for all of my network functions. And then I would have some descriptors on how those VNFs and those network services are defined, some languages to model those service definitions. And then through it all, there are standard APIs defined on how the different layers speak to each other and how we would expose APIs or interfaces to the standard telco OSS and BSS systems that run the telco businesses today. And this picture here shows Juniper's NFV reference architecture. We laid out this picture on purpose to kind of show how it overlays on top of that ETSI reference architecture we showed previously. And so then starting from the bottom left, we have some NFV infrastructure. This is the traditional Juniper network hardware that you're all familiar with, MX, virtual MX, metafabric switching architectures to support the data center infrastructure to connect the compute layer together. Also part of the NFVI is a compute and storage layer. And of course, Juniper doesn't make these products, but we have some great partners that we can work with to help with turnkey solutions and bring things to market. Above that NFVI layer, we have some virtual network functions. This would include the Juniper VNFs, our virtual SRX firewall, and our virtual MX routing platform that we'll talk about a little later. We've also got full support to onboard and orchestrate third-party VNFs, or virtual network functions that may come from other vendors or even the open source community. On the right there, we have the MANO layer, management and orchestration layer that we talked about before. And within that, there are several platforms that Juniper delivers and also interfaces into third-party elements. So from the bottom up, we've got Contrail networking, which is our market-leading SDN solution for data center. The Contrail cloud system on top of that, which is our OpenStack distribution, packaged with Contrail networking to deliver an OpenStack compute infrastructure to support VNFs. And also part of this solution set is our Northstar controller, which is our wide area focused SDN layer for orchestrating MPLS networks. And then we have our VNF manager, which has awareness to our VNFs and also interfaces to bring in third-party VNFs into the system. And then some management tools like Juno Space and other things that, if you're familiar with Juniper, you're familiar with those tools. That all makes up the MANO layer, but key to that is the Contrail Service Orchestration Platform, which is our relatively new orchestrator that would sit above this MANO layer and allow you to create new services, to define network services and templates, and allow some self-provisioning tools for some of the use cases that we're going to get into a little bit later. Sitting on top of that would, of course, be the telco BSS and OSS system, and we have a really strong ecosystem of partners we work with there. And what this enables are some new solutions. Some of these are new managed service solutions like virtualizing CPE, and some of them are improving existing infrastructure like virtualizing the PE layer or maybe your GI LAN infrastructure. And so we'll touch on some of these solutions a little bit later on in the presentation. And of course, key to this whole solution is openness. Juniper's been very focused on being very open in our solutions all along, whether it be through open standards or even through open source, as is the case with our Open Contrail solution. The Contrail Service Orchestration Platform in particular, the orchestrator that we use, has a set of open APIs. Going from left to right, we have a network service design application, which uses a Yang model catalog, which is a standard tool set and modeling language to define network services. That is where we would define the network service that we're going to offer to the end customers. We would create these network service templates, whether that network service be for GI LAN or cloud CPE or virtual PE. Those service templates would be stored, and then those service templates would be presented via a well-defined and documented REST API that we would expose to a user portal or to an OSS BSS system. And then, of course, the Contrail Service Orchestration does have a really nice-looking GUI, a user administration with an admin portal and a user portal that we can use as the self-service interface for network services, or we can use those same APIs that we've developed our applications around and present those to the OSS system. Looking down below that, this network service orchestrator piece of the Contrail Service Orchestration platform will speak standard APIs down to heat templates in the OpenStack layer, which is as part of the virtual infrastructure layer, and then we'll use standard APIs down to the VNFs themselves to provision the actual virtual machines for the network service. So we'll get into the workflow a little bit later on, but these are the components that are made up here, leveraging open APIs everywhere and throughout, very simplified to kind of allow a self-service mode of defining network service creation without needing to touch CLIs and really get into the nitty-gritty bits and bytes of the service. The portal and all of the interfaces are very customizable, so a user can create their own network service and can customize the portal to their needs. And of course, everything across this is automated, because that's key to NFV and these cloud technologies, is that the solution and the deployment of new network services are automated. So this modular architecture allows us to automate at every level and even integrate other languages in, or other plugins or other interfaces where required, to make sure that the network service and all of the administration of these network services is automated throughout. The Juniper NFV architecture is extensible. We're leveraging virtualized MX and virtualized SRX as virtual network functions across the solution. Of course, we can build solutions with other virtual network functions, but we're actually very excited about our VMX and VSRX platforms. We have complete feature parity from the physical MX to the virtual MX, from the physical SRX to the virtual SRX, so that we've got feature consistency and can offer consistent services across physical resources and virtual resources. These products and these virtual platforms are very carrier grade. We're using the same code and all of the same protocols and elements that we use in our hardware solutions, in our software-based solutions. And then we give you complete control across physical and virtual through a consistent automation platform, so that we can really control the pace of deployment based on specific business goals and objectives without really having any operational penalty from needing to translate my operational processes from a different physical platform to a different virtual platform. So that consistency across all of these elements gives us a great way to control the rollout of new services and manage those without really changing a lot of your operational practices. So the Juniper NFV reference architecture provides a fully automated end-to-end service lifecycle process to allow you to manage these network services in a completely automated way. So what we're showing here is an example of the steps that we go through to create a new network service and implement it into the network. So first, the administrator is going to onboard and validate a catalog of network services. And this means that they're going to define what that network service is going to provide. Let's say, for example, it was a virtual CPE service with connectivity into an IPVPN. That service definition might include what might run at the customer premise site, maybe some WAN acceleration. It would include maybe some routing policy that would have to happen on the core network and on the MPLS WAN to connect that IPVPN together. And it might include a service virtual machine or two to run firewall or DPI or something back in the centralized data center on the NFV infrastructure. But all of those elements and all of the pieces that make up that network service would be defined and cataloged into this service catalog as part of the Contrail Service Orchestration platform. Second, we would create and associate and manage user roles. So if we're onboarding a new customer, we would define who the administrator is and who the end user is and what those privileges are. And then at step 3, the user, which would probably be the IT administrator for the service provider's customer, would instantiate that network service from the user portal. So they would log in. They would choose the network service that they're allowed to provision. Maybe this is delivering a new CPE device out to the end, to a remote site. and that CPE device includes a given service definition. So the user would choose the appropriate network service for the implementation that they want to instantiate. And then we would instantiate the network service workflows. So this would kick off the process within the orchestrator to go actually establish the network service. The orchestrator on step 5 would look at the resource allocation based on KPIs or performance indicators and SLAs that were defined when we actually created and cataloged that network service in the first place. And then what we're going to do is we're going to basically compile that template or that service definition along with all those performance KPIs into a services configuration, forwarding graph, the instance connectivity, all of the things that are required to make this network service a reality. At step 7, what we're going to do is actually go configure the network. So we're going to go talk to the NFV infrastructure and tell it to go start some virtual machines. We're going to go talk to the physical infrastructure through netconf or Yang or maybe a Python interface to go deploy those network configurations on the physical routers and elements where required, and actually provision things using automation to implement that network service. And once that network service is up and running, we're going to continually monitor and analyze that service to make sure we're meeting those SLAs and KPIs. And then if we're not meeting those, or maybe we need to change the network configuration or the service provisioning to support those KPIs, we have the ability to dynamically scale up and scale out that NFV infrastructure as the needs change.
Scott, this is a really interesting area. As I talk to service providers globally, rolling out new services is so critical to their futures. But even maybe more important is the day 2 operations of the entire service lifecycle management. So maybe this is a question for Jitendra, really around, we've got so many possibilities here, but often we get the question of, where do we begin? How do I begin started with this type of process?
Thank you, Wayne, for that question. That's an excellent question. If you look at what Scott has been presenting so far, there are so many moving pieces to this NFV architecture. This is where we come in with the assessment service. What that helps us offer the customer is look at the customer's existing network services, look at the target goals for them based on the NFV architecture, and then do a gap analysis and help them chart a path to go from the current architecture to an NFV-based architecture to deliver all of these services in an automated fashion from a cloud-based architecture.
And of course the solution is secure from end to end, and we've got policies in place to secure the NFV infrastructure itself. But what also is enabled here is a new way to offer security as part of the service. So we've got policy-driven role-based access control for the NFV infrastructure. So there's an administrator role that can create services, and then it's multi-tenant, so we can delegate authority to enterprise users and their end users. So people are only able to affect what they're authorized to affect. But implementing all of these services in an automated and centralized way actually gives us a new sort of visibility point into the security posture of the network and how we implement security policy. So one of the benefits of moving into a fully automated and centralized approach is we move away from individual firewall rules that are manually touched on every firewall at every branch office or every physical firewall at each data center edge, and all of that is driven through this self-service portal through a centralized policy engine. So then my checks and my need for visibility and where those security policies are deployed are greatly simplified by being able to go back to a centralized place and understand where security policies are implemented. And I know that the security policies were correctly applied because we're using automation tools to implement those security policies instead of relying on manual process. So not only is the time to deliver the new service greatly accelerated, it's also better secured through automation, eliminating manual processes and the possibility of manual mistakes. Another element that's enabled through leveraging NFV technologies is dynamic scaling. So dynamic scaling is a concept that has existed in cloud environments and cloud applications for several years. The idea of scale up or scale out. So if I have an event in a web service, or let's say everybody wants to watch the latest TV series that was posted to a streaming service, the cloud infrastructure that supports that web series or TV series can scale or add new capacity on demand because they're using a pool of resources instead of dedicated hardware or dedicated devices for each service. This same idea of scale up to respond to demand is an integral part of an NFV solution, and the Juniper reference architecture certainly supports this. So the environment is very elastic. We would build this on top of commodity compute tools that are provisioned as a pool of resources available to the network service, and then the orchestration platform would be monitoring the KPIs and the SLAs of those network services, and also the capacity of the infrastructure to support those services. And if we're not meeting an SLA, we can define rules on how we scale up and scale out that service. Maybe if I'm providing a firewall service on a virtual machine, a virtual SRX for instance, I could maybe add some CPU cycles or some RAM to that process on demand in a lot of cases, or maybe even some network capacity, or by increasing the allocation of network bandwidth to that service. And I can also add more. So, if I started to get hit through that firewall quite a bit, if it was front-ending a web service or one of these TV series, I could even add additional firewalls scaled out across that compute platform and then load balanced across those firewalls just to handle the load when needed. And also really key here is scale back or scale down. So when a service is deprovisioned or that demand goes down, we can automatically deprovision some of that compute resources and some of those virtual network functions that were required so that I don't have wasted resources just sitting there spinning and not being fully utilized. Key to any NFV architecture is going to be support for third-party virtual network functions. Of course, Juniper doesn't make a virtual network function for every possible network service that you might want to provide. We're very proud of the virtual MX and the virtual SRX and the sorts of advanced things that we can do with those VNFs. But there's a whole ecosystem out there of other vendors that are building virtual network functions that a service provider might want to use or offer. And there's a very rapidly growing open source community also developing virtual network functions and tools to support NFV infrastructure. And so we've got a great framework in place as part of our reference architecture to support these third-party VNFs. So we've got support standard and open protocols and APIs. We've got a very simple and also standard-based Yang model that lets us easily integrate third-party network services. And then, this really opens up the ability for the service provider and the community to continue to innovate in these areas, developing new VNFs, porting new VNFs that might run on the NFV infrastructure. And the Juniper reference architecture is right there to support that innovation and allow running of those sorts of innovative VNFs on top of our platform. And the last element of the technology that I want to talk about is the ability to service chain these functions together. And so what is a service chain? Well, when I think about how I used to provide a network service, let's say I wanted to put a firewall service in front of a set of web servers and then connect those web servers out to the public internet. Well, I'd have a line that comes into an edge router at the data center, and I'd probably pull a wire off that router and plug it into a physical firewall, and then I'd pull a wire from that physical firewall and plug it into those servers. And yes, I'm oversimplifying because I'd probably have switches and things along the way, and there'd be other elements involved, but I was physically chaining devices in line to make sure that I'm providing the right service to the end user. And this same thing happens in mobile networks and other telecom network services. Well, if I'm virtualizing all these things and all of my firewalls and EPC elements and other services are running just as virtual machines on top of shared compute infrastructure, how do I insert a service in between? How do I place a firewall in front of that web server in a virtual world? Well, the way we do that is through service chaining. Service chaining is the idea of just logically plugging things in. And instead of passing a packet directly from point A to point B, we have some policy defined in the network that essentially redirects that packet to a service VM or a service piece of hardware to provide that extra function on top of that packet before it's sent on to its end destination. And so service chaining is an integral part of the Juniper NFV solution. Contrail networking, our SDN platform, is very advanced in how it's able to provide some really interesting service chaining use cases within the data center. And we encourage you to go to our website and read all about this and look at some of the interesting things we can do even beyond NFV use cases. But it's a very simple GUI and set of APIs to define those service chains or composing network service. And then, of course, implementing those services is fully automated. And then the policy framework for defining those service chains and getting really creative on how I direct packets is very, very advanced. And all of those functions and how we do this sort of creative packet manipulation is very, very scalable and very, very carrier grade. So with that, I'll hand it back to you, Wayne, and we'll talk a little bit more about how we actually get it done.
Scott, thank you for that comprehensive overview of Juniper's NFV reference architecture. You've done an excellent way of explaining a complex technology in a simple manner that I think our attendees will find very educational. Now we're going to go on with Jitendra, who will talk about how do our customers do this in terms of executing with NFV technology to transform their architecture for service delivery.
Thank you, Wayne. We'll take a few moments here to talk about the different services we have as part of the professional services offerings for the customers, which will enable them from the very beginning, from identifying the opportunities to do assessment and how to go ahead and build these technologies and infrastructures in their own environments and be able to deliver these services and get all the benefits of this transformation. This slide shows various Juniper professional service offerings that can help the service provider transform their network services. Let's say if you're a service provider and you have been thinking about NFV-based services. However, you don't know where to start. The ideal PS offering to start with would be the Cloud CPE Service Creation Advisory. What this allows a service provider to do is identify business service opportunities that can be enabled using cloud-based CPE services. Once you've identified the target opportunities that a Juniper Cloud CPE solution can unlock, then what you need is a clear, structured roadmap highlighting key milestones and dependencies to be able to deploy the solution. This is exactly what the assessment services provide. Basically, a professional services solution architect does a gap analysis to chart a logical path for deploying cloud-based services in the customer's specific environment. The last piece of the plan phase is doing the detailed design. A PS solution architect can put together a cohesive end-to-end solution design covering all aspects of the Juniper Cloud CPE solution, working with different solution elements and teams. Juniper PS also helps customers deploy these solutions. Since Juniper Cloud NFV architecture is based on an open systems philosophy, we also support integration of third-party elements and third-party VNF functions. The field trial service allows a customer to get a first-hand feel of the solution and shorten the learning curve. We also have offerings to help customers run the day-to-day operations of a cloud-based CPE solution and keep the innovation wheel spinning by providing skilled on-site expertise. Lastly, no transformation would be complete without empowering the customer's in-house teams with the right knowledge and skill set, which includes providing them with customized knowledge transfer workshops. One of the common worries of adopting an open system solution is with the integration of different elements from different vendors. Customers are typically worried about being able to integrate and run third-party VNF functions. We address these concerns and provide necessary VNF lifecycle services, which include testing with different third-party VNFs on Juniper NFV infrastructure using automated testing frameworks. Juniper PS basically offers 4 levels of VNF validation services. As you see on the slide, these levels are access, interop, scale, and high-performance related test cases. The access basically provides the remote access to a Juniper NFV infrastructure and a test environment, including the latest version of Contrail controller, OpenStack, and Contrail service orchestrator. This enables customer or a third-party VNF vendor to confirm basic operations in a very cost-effective manner. The next level, interop, basically adds validation by Juniper that the third-party VNF interoperates in a Juniper NFV environment. And scale testing adds load testing of a provided VNF on Juniper or a customer-provided hardware. Lastly, high performance adds highly customized service for complex service chain environments. The transformation journey might be different for each service provider. However, certain stages and milestones remain familiar in all success stories. Lab testing to verify the proof of concept remains an invaluable learning tool. Juniper enables customers to successfully build POC labs in their own environments or utilize Juniper's open lab resources. It is an important step, especially when adopting a new technology, to have a better understanding of the final solution and validate whether the technology can deliver a required solution and also identify any skill set gaps. A market or a field trial is a low-cost, low-risk, tactical option available to service providers. It validates the solution and various assumptions. It reduces the learning curve to adopt the new technology, fine-tune processes and the solution, identify and solve any technical or integration challenges. The field trial service is specially designed to help service providers get a taste of the technology and the solution in a small time frame with limited and controlled rollout in the production environment using existing customer channels. The solution and various processes can be evaluated, fine-tuned to better match expectations before a full-fledged deployment can take place. Once the solution is fine-tuned, a larger network-wide rollout can start with deployment and migration of the services. This can include integration with all of the OSS and BSS systems. Lastly, knowledge transfer is key to completing successful transformation process. It enables the customer's staff to continue the innovation cycle. Customized operations guides and training workshops can be delivered based on the requirements. Juniper has been a leader in innovation and transformation of various service provider domains, like the core and data center, among others. Juniper has been involved in transformation of some of the largest carriers and early adopters of the cloud CPE architecture. Juniper PS follows a robust and proven transformation methodology, which is supported by Juniper Project Management. We leverage a well-defined, open, extensible, and tested end-to-end solution reference architecture, which utilizes various automated testing frameworks for faster and consistent results. We have a highly experienced and competent team of solution architects, project managers, solution consultants who have a diverse and cross-domain expertise to deliver a seamless and end-to-end solution design.
Thank you, Jitendra. That was an excellent overview of how professional services at Juniper
is really helping our customers transform their service delivery network using Juniper's NFV reference architecture. And now, Scott, back to you to walk us through how different illustrations of how customers are using this technology from a use case perspective.
Thanks, Wayne. So there are many, many use cases for this technology, and we do see quite a variety around the world of service providers and even large enterprises deploying NFV-based solutions. What we've chosen to do is briefly go over 3 of the highlighted use cases that we see very near term at this time. The first use case that we see is one around managed CPE, where the service providers are looking to frankly optimize the operation of their branch router and managed CPE services. Today, there's a lot of truck rolls and manual process to install routers and firewalls at customer locations, and we've got to send a trained technician out usually to configure those routers at the customer location. We don't have good centralized troubleshooting tools, and the hardware that goes out there is really quite expensive. And so one of the most immediate use cases for NFV technologies that we're seeing in the marketplace today is a optimized and simplified virtualized CPE solution. And so what Juniper's brought to market here through our Cloud CPE package, which is leveraging our entire NFV reference architecture, what we've brought to market is the ability to offer a very flexible CPE solution set, where there's flexible options of centralizing all of those CPE functions and just deploying a really simple network interface device out of the customer premise. There's the option to distribute those network functions out to the customer site, but doing so on a platform that supports virtualized network functions instead of implementing a stack of boxes at every branch office. Or, of course, there are hybrid models that would blend the two together. But all of these services are orchestrated by the Contrail service orchestration platform, presented through the very simple service creation interface that we talked about previously. And we're eliminating truck rolls. Onboarding of new CPE devices is fully automated. We don't need to send a technician out there every time we turn up a new site. Changes are managed through that central site. All of the provisioning steps are automated. And this particular solution has been very popular with service providers around the world. The next use case that we've seen quite a bit is a virtualized PE, or virtualized provider edge, or MPLS edge router. And this is the idea of taking things that may have run on a PE router like a Juniper MX and running those on virtual machines back at a central office or in maybe national and regional data centers. Feature for feature, function for function, it's very similar to what you'd do on a physical router, except that you're sort of getting into a pay-as-you-grow model, because instead of deploying a big router that's full of features, you can simplify some of the network infrastructure, and then a lot of those features are provided out of virtual machines running in cloud infrastructure. This gives us the ability to scale up and scale down, again using those elastic scaling characteristics that we spoke about previously, and really enables and opens up some options for automating services, allowing for self-service provisioning, and all of those kind of inherent benefits of an NFV solution. And the last use case that we're going to talk about today is this concept of a cloud brokerage. And what this is really opening up the opportunity for a service provider to provide new services, interconnecting their enterprise customers to public cloud providers. And doing this basically involves running a virtual network function in that cloud provider as a virtual machine. So taking a virtual SRX or something like that and terminating an IPsec tunnel over in that cloud side of things, or maybe a virtual MX terminating into a direct connect circuit like you might have with Amazon or some of the other large-scale cloud service providers. But then tying that back into the service provider network so the service provider can offer their SLAs and services that they would be providing over their IP networks today, and just extending that off-net into public cloud providers to open up some new service opportunities. This gives us the ability to maybe be flexible about where services are offered. Of course, end-to-end security is key to these sorts of things, and managing things through an NFV infrastructure, through that centralized management architecture lets the service provider provide an end-to-end security solution to their customers extending into public clouds. And then all of it is driven, again, from that centralized policy management and control framework that's part of the NFV solution set. So with those use cases, I'd like to hand it back to Wayne to wrap things up.
Thank you, Scott, for that excellent coverage of the use cases and where NFV technologies can really apply to solving customer problems. So across these use cases that Scott has talked about, we can really start to see why this technology is so transformative in nature. If you look at the infrastructure aspects of it, being able to create and improve services with greater agility, faster fulfillment models through automation, and really being able to rapidly evolve those services either into new markets or new customer segments or even geographies is really going to also require that end-to-end lifecycle management of these services across these new service models. So across the infrastructure, Scott has really gone through the key components of the architecture, the use cases, and you can start to see how these technologies become so transformative in the infrastructure itself. Then taking this further, we start to look at the business impacts of this, right? Looking at the CapEx and OpEx optimizations that this virtualization technology can bring to the table. So therefore, with lower risk, you can start to capture that new opportunity with much greater flexibility and lowering that risk of the investment needed to be able to capture that. So therefore, you combine that with the operational capabilities and that being able to translate to more simplified workflows, and ultimately what that means through automation and a software-driven model is lowering your overall OpEx expenditures to achieve these goals. And a side effect of that is really the compliance risk associated with it. Because you're automated, you have greater visibility into your network. Those type of compliance measures that you have to meet on a regular basis, you now have that information at your fingertips. And so we've touched upon this in terms of the risk factor, low risk to enter markets. If you have a wildly successful service, you can then dynamically scale those operations up. If for some reason that service is unsuccessful, you have a fast-fail methodology that you can reuse that infrastructure and that overall reference architecture and apply it to a broader set of use cases and spin down the ones that are not so successful. These are really the opportunities that Juniper's reference architecture is bringing to the table with you, and we're very excited about the transformative nature that this is taking hold. So with this transformative technology, it's still new, and so therefore really what customers are looking for is a trusted partner that has a level of maturity with this technology and the experiences to bring this to market. And as a result of that, Light Reading has done a survey, and the result of that is Juniper Networks has been voted as the #1 most trusted vendor to deliver on this next generation technology. We're very excited about that and very proud of it. This has also manifested itself in terms of customer experiences and customer engagements, shown here with Telefonica and Telecom Italia, and many others globally have leveraged this capability set that Juniper has to offer to really change the way that they're making architectural decisions and building a network that will be successful for the long term. So this brings us to the wrap-up slide for today's Technology Transformation webinar. We're very excited about where this is going to take us. We are continuing to innovate in this space. We have been a leader in the networking and cloud innovation, influencing IP decisions for many years now, and we're taking this up several notches through virtualization, demonstrated here with our Virtual MX platform and a Virtual SRX platform, leveraging the disaggregation of that software into a virtualized format and innovating with further capabilities around MANO, software-defined networks. So this is really an exciting juncture. And lastly, trusted technology partner. We've done this. We know the DNA for constructing these changes and shifts in the market, and we're very excited to work with you to take foothold of SDN and NFV in your architectural decisions going forward. To learn more about Juniper's approach with NFV, our NFV reference architecture, and use cases, I invite you to visit our NFV Solutions page, which will be a repository for a lot more white papers, use cases, customer testimonials on our overall NFV approach. This brings us to the conclusion of today's webinar. I'd like to thank you for taking your time to listen to us today. And I'd also like to thank Scott and Jitendra for sharing their experiences and their knowledge around NFV with us. Please join us next time for a webinar on the organization of the future. And until then, please visit us at Juniper's Big NFV Idea page to learn more about our overall NFV approaches. Thank you very much.